All right, and let's remember really quickly, if we're solving by graphing, what happens when the lines were parallel? What did we get in that situation? No solution. And what happened if the two lines were right on top of each other when we graphed them? Infinite number of solutions. Nice. And when we solved by substitution, how did we tell that we got no solution? A number equals another number, like 1 equals 0. Something impossible. That tells us we get no solution. And for solving by substitution, how did we get an infinite number of solutions? Number equals the same number, like 6 equals 6. That tells us we have an infinite number of solutions, because that's always true. All right, so I just wanted to remind us of those. So today, when we solve by elimination, what we're going to do is we're going to add the equations together to eliminate, make it go away, to eliminate one variable. And it's nice because the process is really pretty easy to do. So these eliminate one variable, that's what we call it, elimination. So let's look at an example. We've seen lots of systems like this. Negative 2x plus 12y equals negative 30. Is this what I wanted to do? Let me see if I think there's another one that I wanted to do first. I want to do that one first. There we go. (3x plus 4y), sorry about that, equals negative 22. And 5x minus 4y equals 38. That's my system of equations. Now we could solve this by graphing. We could get y equals by itself on both sides and graph those two equations. It'd be a fair amount of work because we have these numbers here. We could solve by substitution. Okay, we could get x or y by itself. Looks like we'd get maybe some fractions involved there, maybe. But when I look at this equation, I see that I have a plus 4y here and a minus 4y there. What do I get when I add plus 4y and minus 4y? 0. So what I'm going to do is add these equations together. So 3x plus 5x is 8x, plus 4y minus 4y is 0, and negative 22 plus 38 is 16. So I added those two equations together. Now I can divide by 8, and I get x equals 2. So I've already found x. This is nice. Now I can plug this in to either original equation. So I'm going to plug x in equals 2. I chose the first equation. So I'm going to plug it in right here. So I get 3 times 2 plus 4y equals negative 22. Well, 3 times 2 is 6, plus 4y equals negative 22. Subtract 6, and I get 4y equals negative 28. Divide by 4, and I get y equals negative 7. So my solution is the point 2, negative 7. Yes? Yeah, you substitute, and I can substitute this into either one of the original equations to get the other variable. Yes?
When using elimination, can you subtract here or
So you can subtract. Usually what I suggest is that we stick to adding because it's easier to make arithmetic errors when you subtract. But you can do substitution by subtract. All right. Questions on what we did there? And isn't that nice how this works out? It's quite a bit less work than the other two methods.
And this equation only has one solution, right?
One solution to -7. All right, let's look at a situation where these two are not exactly opposite and see what we do then. So I have 2x plus 4y equals 22, and 2x minus 2y equals -8. Well, this time, I see I have a 2x here and a 2x here, but they're the same sign. So I could subtract, but my suggestion, instead of subtracting, is that we always try to add, because it's easier to not make arithmetic errors. So to make one of these, I want to make one of these negative. So in order to do that, I'm going to multiply the entire second equation by -1. So I'm multiplying this entire equation by -1. And I'm going to distribute that -1 to everything in the parentheses. So my equation, then the top one's not going to change. -1 times 2x is -2x. -1 times -2y is plus 2y. And -1 times -8 is +8. And now I can add. When I add these two together now, 2x plus -2x, I get a 0. 4y plus 2y, I get a, make sure I did this the way I wanted to. Okay. 4y plus 2y is 6y, and 22 plus 8 is 30. Divide by 6, and I get y equals 5. And now I can substitute y equals 5 into either of the original equations. 22 plus 8. 22 plus 8, yes. Now I can put y equals 5 into either equation. So I'm going to put it right there. So I get 2x plus 4 times 5 equals 22. 2x plus 20 equals 22. Subtract 20. 2x equals 2. Divide by 2, and x equals 1. So my solution is the 0.15. Yes? I multiplied everything by -1 so that I can make this 2x negative. Because I want to add them together to eliminate one of the variables. Yes?
What I think he's trying to ask is why would it be -1, not 2 here? So, like, why would you just use -1?
Because all I want to do is change, I don't want to change the numbers, I just want to change the sign from positive to negative. I want this to be a -2. So to make this a -2, I have to multiply by -1. All right, other questions? Yes. Yes. It's just when you subtract, in my experience, when you subtract, it's easier to make an arithmetic error when you subtract. Because you have, for example, 22 minus negative 8. So you have 22 plus 8, and it's 30. But a lot of times when you do a minus and negative, it's easy to forget that we do a positive. So my suggestion is always just to always add. Do something so you can always add. All right, let's look at another example that's not quite as easy as this one, but the same idea. Negative 2x plus 12y equals negative 30, and 3x minus 4y equals 17. Well, now I don't have anything that really matches up in either of the equations. In this situation, we can multiply by some other number to get what we want. So I'm looking at this 12y and this negative 4y. Could we multiply this negative 4y by something and make it negative 12y? Yeah? Let's multiply by 3. I'm going to multiply this whole equation by 3. And when I do that, I make this into a negative 12y. So my equations then are negative 2x plus 12y equals negative 30. And I'm going to distribute everything here. 9x minus 12y equals 3 times 17 is 51. Yes? Yes. Well, now I have a positive 12y here and a negative 12y there. And now I can add these two. Negative 2x plus 7x, or sorry, plus 9x is 7x. Negative 12y plus negative 12y is 0. Negative 30 plus 51 is 21. Divide by 7, and I get x equals 3. And I can plug x equals 3 into either original equation to solve for y. Yes?
So do like the two numbers you cancel out automatically, like the positive and the negative?
Because we're adding them together. Positive 12y, negative 12y adds up to 0. So I plug that in there, negative 2 times 3 plus 12y equals negative 30. Well, this is negative 6 plus 12y equals negative 30. Add 6 to both sides, and I get 12y equals negative 30 plus 6 is negative 24. Divide by 12, and I get y equals negative 2. So my solution is 3, negative 2. All right, questions there? All right, we can also get a situation where we need to multiply both equations by some number. So let's look at a situation like that. 2x minus 3y equals negative 12, and 3x minus 2y equals 2. So we don't have anything that really matches up. But could I multiply this equation by some number and this equation by some other number to get the same numbers in front of either the x or the y? Or what could I do here? Multiply the top by 2 and the bottom by, do we want 3? Because we want them to be opposite signs. So how about negative 3? That way we would get a negative 6y here and a positive 6y there. So when I do that, I'm going to distribute to everything here. I get 4x minus 6y equals negative 12. And here, negative 3 times 3 is negative 9x. Negative 3 times negative 2 is positive 6y. And negative 3 times 2 is negative 6. Now, these two are exactly the same, but with different signs, a positive and a negative. So we can add them together. Yes? Thank you. That's a kind of arithmetic mistake I make when I'm solving by elimination, is I forget to do the multiplication. And that's also kind of like why it's easier to add than subtract. All right, so add these together. 4x plus negative 9y, sorry, negative 9x is negative 5x. These, negative 6y plus 6y is 0. Negative 24 plus negative 6 is negative 30. Divide by negative 5, and I get x equals positive 6. And I can substitute x equals positive 6 into either equation. I'll plug it into this one this time. So I get 3 times 6 equals negative minus 2y equals 2. 3 times 6 is 18. Minus 2y equals 2. Subtract 18 from both sides. Negative 2y equals 2 minus 18 is negative 16. Divide by negative 2. And I get y equals 8. And my solution is the 0.68. All right, questions there? So this one we had to multiply by 2 different numbers to get the things that we wanted to add together to give us 0. All right, let's look at one last example. All right, so here's our system of equations. We want to solve this by elimination. How could we start here? And I'm going to say, let's look at this and this. Yeah? Multiply the bottom by negative 4. Nice. So if we multiply this by negative 4, negative 4 times negative 2 gives me a positive 8y. And then when I add those, they go away. So I have 12x minus 8y equals 20. Make sure I do my multiplication here. Negative 4 times 3 is negative 12x plus 8y equals negative 20. I'm going to add these together. 12x minus 12x is 0. Negative 8y plus 8y is 0. 20 minus 20 is 0. I get 0 equals 0. That tells me, yes, I have an infinite number of solutions. Something like 0 equals 0 always tells us we have an infinite number of solutions. If we would have gotten 0 equals 5, that would have told us no solution. So we can get the same situation coming up with solving by elimination as we did with solving by graphing and solving by substitution. Okay, and everybody clear here why we wanted to multiply by -4? That's how we got one of the variables to go away. Okay, so tomorrow we will work on a little review, solving by graphing, solving by substitution, solving by elimination, and then our test on block day. The problems they're going to ask you, solve by substitution, solve by graphing, or solve by elimination. And I think there are 6 questions plus some PSAT questions again on this test, so it's not a long test. It's just those 3 topics: solve by substitution, solve by graphing, solve by elimination. Our homework is page 382. This is section 6.3. 382, 16 through 26 even, 27 through 29, and 38. As soon as everybody gets that written down, I will show the KYOT. There you go. You're welcome. Yeah. Let me